Welcome to Research Centred at UCD. My name is Phil Smyth and I am here today to give you a little behind the scenes look at research that happens in centres in UCD. World class, leading centres. And what do you do in order to find out what they do? Well, you go and talk to the people who are working there, the experts. So who are these experts? Well, they are young researchers working at the cutting edge, the coal face of research in Ireland and the world, making it a better place. And the first research centre that we're going to take a look at is Icrack. So Anna, thanks for joining us. What is Icrack?
So Icrack is the SFI Research Centre for Applied Geoscience. So what we mean by that is that we're interested in researching problems that are critical to society and the economy. So when we talk about a low carbon future, we're talking about decreasing dependence on fossil fuels and renewable technology. But although the energy is considered renewable, the actual things that produce the energy are not. They have to be taken out of the ground. So an example of this would be like electric cars have a lot of metals in, lithium and cobalt. And as we build more electric cars and we build more wind turbines, then we need more metals.
Okay, and how did you get, because like obviously I want a Tesla, I want to go very fast, I want to sleep and actually have it drive me to somewhere. How did you get into geosciences and that? What spawned your love for what I would be like, it's rocks, isn't it? Isn't it rocks?
I mean, it is rocks, but rocks are everywhere, and they're all different. I mean, actually, I think my story started when I was a teenager, and I was in Iceland, and I realised that I was sat in the middle of a caldera, which is like a massive crater that was so big I didn't even notice I was sat in it. It was just these mountains in the distance, and I was thinking, that's incredible. How on earth did this form? And that was sort of what sparked my interest in geology, really.
So you were just sitting in the middle of a crater going, this is awesome. You brought something with us today, because I can still see it here, and I'm fascinated to know what exactly, is this your pet rock that you bring everywhere?
Pet rock that I carry with me everywhere. Well, I was saying that I actually forgot to bring this last time, and I probably
we have it today.
Should carry it with me everywhere, I've been advised. Yeah, this is just a bit of a rock that's actually from Central Africa, and it contains copper sulfide, which is one of the minerals we look for when we're looking to find copper. But it also contains this big blue mineral, and that's my favourite mineral. That's Kyanite.
My favourite mineral. It sounds like your first book title.
It brings out that sense of childish glee in me.
Why? Well, yeah, I can see it. It's gone.
So Kyanite forms really, really high pressures, meaning you have to bury it really, really deep. And this rock has not been buried deep. And yet it's grown with copper. So if we can understand why this metal grew, maybe we can understand where to find more.
And this is, of course, why Icrack is the Centre for Applied Geosciences. It's actually the application of science and research. And what we're going to do right now is go to another researcher and see what else Icrack is up to right at the cutting edge of rock faces. So cool, we just heard from Anna about what Icrack is and how she got her start in geosciences. How did you get into this?
Oh yeah, I got into geosciences because I guess I love nature, going out hiking, the outdoors. And then I was doubting between different choices. And then at the end, I chose geology because it combines so many different aspects. It combines the natural environment, combines physics.
Yeah, and you love saying that being out in nature. We were just chatting earlier on, like I love going on walks with geologists because like you're like, oh, look at this, and this is where a river used to be, and it's great. And you even do that in nature with poetry sometimes, is that right?
Yeah, we with Icrack, we organise some events combining geology and poetry, and I love it. We take out the general public, people out for walks, explaining the geology, but we tie an element of landscape poetry into that as well, and it's magical. Yeah.
Well, that really, because it's about life and poetry and bringing kind of science and art together, which is really, really nice. And I suppose what's also really nice is the work that you're doing has a real impact on what's happening in the world. What are you working on right now?
Yeah, so one of the major projects I've been working on is to understand what's beneath our feet in Ireland itself. And the reason that's important is because as we're going into a transition into more renewable resources, etc., we're needing to find raw materials to build our windmills, to build our electric vehicles. And we need to find these resources, and that's where I'm helping to find these beneath our feet.
So when you say you're going to find them, do you go out and literally kind of just sort of like No, nothing here. Walk somewhere. No. How do you actually, without being crude, how do you actually find out where things are?
Yeah, so this is where I guess the element that I love comes in, is combining all the different things, elements of what we have. So we can combine all different types of data to model essentially 3D geological modeling of the Irish subsurface. And that's by listening to the Earth. Okay. Or by looking at samples from the Earth.
So taking samples, I can get them out. The listening to the Earth really interests me because he conjures up the image of nearly like an ultrasound.
Yeah, ultrasound is actually a really good analogy. So what we do is we send sound waves, vibrations into the Earth, and we look at the reflections of those sound waves on rock layers or certain items in the subsurface in the Earth, and then see what the signal comes back as, and we can look at these very similar to an ultrasound and combine that with all kinds of different data into our 3D geological models.
Oh, so you're really taking like the sound, almost like the music, almost like the poetry of what's coming like in the life. I'm coming up with Mother Earth, coming up to see what we can provide ourselves.
Very poetic.
Ties in perfectly with what you do.
Yeah.
Thank you so much.
Cheers.
So we kick things off with Icrack, and it's nice to meet the people behind the research, and we're going to do that again now, and we're going to get a little insight into what else is happening here at UCD. So Ira, thanks for joining us. We're here at Insight. What does Insight do?
So Insight is a multidisciplinary research centre that includes researchers here in UCD and DCU and in Cork and Galway as well. It includes engineers and scientists and physiotherapists and machine learning and statistics experts.
Were you always interested in science?
Ultimately, I wanted to do biomedical engineering, and at the time that wasn't an undergraduate degree that was available. So I ended up doing biomedical towards the end of my degree, and then a postgraduate or PhD in biomed engineering. And then I went to work in the medical devices industry for 8 years, looking at gait analysis and sleep and respiratory monitoring using wearable sensors and non-contact sensors.
Yeah. So that's what we're going to have a look at now, is kind of that sensor aspect towards a medical application.
That's it, and it's the signal processing. So all of them, we're measuring signals from different parts of the body or using different sorts of sensors.
This also means that I'm now going to get a chance to go talk to one of your colleagues and see actually the project that you're working on right now.
Yeah.
Cool, let's go. So Kathy, thanks for saying hello to us. We've had a chat with Emer. She told us a little bit about what Insight is and what she's working on and how she got into science. How did you get started in all of this?
From school, I was always interested in maths and science. They were kind of my favourite areas, and I'd always at home be doing little experiments myself and things like that. And then I just kind of progressed that into wanting to do engineering. Came to a talk in UCD and thought it was really interesting, all the projects they did. I was always more interested in kind of the human side of it, so I started doing biomedical engineering. That's how I got into that. So I much prefer being able to kind of apply the technology and the different aspects to the human body.
That's awesome. What are you working on right now then?
So the way I'm working in Insight, I'm kind of split between lots of different projects. That's how I'm doing it. So I'm working on the same project as Emer, which is the COVID respiration project. And we're doing testing now at the moment to get as many different people as we can to validate our project.
And I saw you looking over at the equipment over there. Are we going to get a chance to try it?
Yeah, we'll get a chance to try it out maybe
like
later
now?
on you, if that's all right.
Yeah, can we do it now?
Yeah. Sure.
Excellent, cool. So Kathy, I've sat here, I've filled out a consent form, I've put on a strap around my chest, I've connected wires. Why have I done this and what's happening?
So the belt you're wearing around your chest will measure the your breathing, so the rise and fall of your chest, your inhalations and exhalations. And then we're also going to get you to pick up the flow head there on your left.
Another thing? Okay, cool. Yes. What's this?
Oh, so
okay.
That'll kind of measure the same thing, but it'll measure your airflow, so your volume in and out of your lungs as you're breathing.
Okay, cool. And this is a little tight for other reasons. I see this. Do I have to put this?
Yeah, so if you put that on, that means that all the air is going to be going through just the airflow.
Sure. Okay, great.
Head.
I'm probably going to sound super. Okay, that's great. So, how do I start? Do I just breathe normally? Sorry. Do I just breathe normally through this?
So what we'll get you to do is do 5 normal breaths, then 3 maximum. So all your air in, all your air out, and then back to 5 normal breaths.
Okay, so 5, 3, 5. I think I can remember that. It's going to go perfectly. Okay, so you tell me when to start. I'll just go. Okay. Okay, so that looks cool. I can see the differences, obviously, when I took the maximum breaths. Why am I doing it though?
So from this, we're able to calibrate your breath volume, basically how much air you're doing, and that's calibrating the belt that you're wearing. And then we'll be able to use that so you can wear the belt when you breathe into your phone next.
So breathe into, okay, explain to me the phone. Why? I saw that the phone
Have
is
the
set up.
phone there, yeah, and we'll open the recording app and you'll be breathing into the microphone so we can hear your breaths through that.
Okay, so when you're saying the recording app, like, so I haven't downloaded anything special or specific for this.
Yeah.
So this is like just my
Voice
sound.
memos or recording.
Okay, so I
app,
have
yeah.
it here. So I have my voice recorder. So I'm going to do the same thing again, but just recording sound.
Yeah, and now we know from the belt, because you did that with the airflow head, we have that calibrated. So now we can use that to calibrate it again.
So do I bring it right up to my mouth?
Yeah.
So 5, 3, 5 again.
Yeah.
Okay.
Do the same again.
Okay, ready. Okay, so I've done this again. I've seen movement again on screen. Why now have I a voice recording now?
So the ultimate aim, I suppose, is for people to be able to record with their phones just at home on their own. But to do that, we need to make sure that it's correct. So we want to use the laboratory grade equipment here to validate our algorithms on the phone.
So that's why I did the initial test with this stuff to like get the gold standard of what the testing is with laboratory grade stuff. But then I can do the same kind of thing once you've proven it with the phone, so people can get assessed by their doctors. They won't even have to go visit them. And with COVID, that's a major leap forward. It's something that's never been done before.
Yeah. So for people to be able to monitor their long-term respiratory changes at home, just with their recording app on their phone.
So it's kind of empowering people as well. But what I love about this is that it's so simple, is that everybody has a phone, but now they can actually use it as a medical device. It gives a real insight into the research. It's almost as if we set that up to what's happening here. Kathy, thank you so much. So we've just come from insight, and what comes after insight? Well, application. And even though there's lots of application in what Icrack and Insight do, and their research is really impactful, we're now going to take a look at a different side of application, advanced manufacturing with iForm. Aoife, how are you? We're in your snazzy lab. Tell us a little bit, what is iForm?
Yeah, so iForm is a centre for advanced manufacturing. So advanced manufacturing, we're trying to really digitise the manufacturing process and improve the manufacturing process.
What are you making then?
So you can make all sorts of things out of manufacturing. That's one of the benefits of it. More so than traditional manufacturing, you can come up with really novel shapes that you wouldn't have been able to achieve before out of manufacturing. So you can see here, this is a polymer printer. So
Oh, a bit of plastic, yeah, I can see that.
yeah. So the polymer gets fed in and gets melted, and then it comes out on a layer by layer basis. So that's what additive is. It makes up the part.
It's like Lego, kind of like that. And you have some examples here which look amazing. You were talking about the intricate shapes, like these look class. What have we got?
Yeah, so these are lattice structures here. So these would have been impossible to have manufactured traditionally. And these lattice structures we use in the medical space, medical industry, aerospace industry. And basically these are just really, really light and have a really high strength to weight ratio. They're very strong.
Oh, so it's particularly useful for those kind of spaces as well.
Exactly. So you're making those porous structures that you wouldn't have been able to get beforehand. And you can see here, this porous structure is also on a medical implant. So that would go into your knee.
It's your knee?
Into your knee.
Oh,
yeah.
okay. If something's gone horribly wrong, right?
Oh yeah, only
Okay.
if necessary.
But so it is, that kind of structure is very intricate and awesome in lots of ways, because you're making things. Or is that how you got into this? Were you always interested in making things, or what was it?
Yeah, exactly. So, as a child, I would have been really interested in kind of nerdy things like maths and science, but also, I felt I was creative. I always liked art. I always liked making things, kind of crafty things. So I feel like, I enjoy being in this space where you're always trying to come up with how to improve the additive manufacturing process for maybe medical implants or, you know, really important applications.
So you're kind of like taking two things you love and actually getting to do them as a job.
Yeah, exactly, and try and improve the process by looking at the signals coming off them. Yeah.
Awesome. And I suppose like it's 3D printing, there's also like much bigger versions of this, and we're going to take a look at something that someone else is working on in a second now.
Yeah, exactly. So we're going to go over to Andrew and have a look at his robotic arm.
Andrew has a robotic arm.
Yes.
Okay, I'm going to have a look at this. All right, I'm going. Andrew.
Hello, Phil.
Yeah, nice to see you. Robotic arm, I didn't feel I was just controller on your arm. That's a little disappointing.
I'm working on attaching it to my arm.
Okay, very good.
For the moment, it's just stuck to a
I
wall.
love it, just as if we didn't know this was there, but like this is pretty awesome. Before we get into this, let's start a little bit with you, if that's okay, and robotic arms aside. How did you get into iForm and where you are here now?
How did I get into iForm? So I got into engineering in general because I really loved Lego growing up, and then went on, and when I got to school I loved technical drawing and technology class and all that kind of stuff. So that's where it led into. And then once I got to university, finished my degree, iForm was kind of getting started, and I started my PhD, did it on 3D printing, and it just kind of ended up going
Just
that
kind
way.
of built layer by layer.
Yeah,
It's almost like the perfect analogy that we've had here, which is
Additive
like,
pun.
Let's get to the robotic arm then, if that's okay. This is the awesome piece of kit. What is it doing and what is it for?
So this particular robot arm, we've retrofitted it, so to speak, to 3D print in composite materials. So you might know carbon fiber and fiberglass and these kind of materials. We're able to print these with the robot arm, and because it's additive as opposed to a traditional manufacturing process, we can do it completely automated, so you don't have to touch it once it's going, and also it can be more complicated than if you were doing it by hand.
Yeah, and I think the fact you said complicated, because I was looking at this and I can see the curve on it. And normally, even when we were with Aoife earlier on, the 3D printer that was there, flat base and kind of top down, and like even obviously printing houses or whatever else, this is another next level above that.
Yeah, so we're still looking at layer on layer, but this time the layers are curved. So rather than just being flat every single time, we're now printing onto this mold here, which just happens to be curved. It could be any shape you want. And then you still do the layer upon layer on top of the mold. And that way it's additive, but complex additive.
Complex additive, I like it. Can we see it in action?
Yes, we can, absolutely.
Use the robotic arm, both of them. Oh, it's quite a high-pitched, not quite noise.
So the noise you're hearing is the 6 fairly powerful motors inside the robot, keeping it in exactly the right position. And this can basically do this all day long, all week long, non-stop, unlike a human.
So this is quite like a robot you'd see it like in the car manufacturing process, that you'd see it like on an assembly line.
It's exactly the same type of robot, yep.
People always have fears of like, robots are going to take my jobs, which I'm like, take my job, I don't want to do it, it'll be great. Is that the idea behind this, that is safety, or what is it?
So part of it is safety.
Could you pause that for a moment if that's okay, because it's...
That's true, it's a little bit loud. There we go.
I love how quick that happens. It's so user-friendly, but go on, is it about taking?
So I'm still in control, which is the main thing.
Which is the good thing. Skynet is not going to take us
no,
over.
not yet. If we give it legs, then we might worry.
That's worrying.
But yeah, so the idea behind using robots instead of people is not just to reduce the number of people working, but to increase the skill of the jobs. So a robot still has to have a person operating it, but maybe one person can operate 2 robots at the same time. And that person will have a higher level of skill than if we had maybe 20 people on a factory line manually assembling things.
So it's a higher output of the skill, but also a higher output of what the factory is doing, and so to a better standard potentially as well. And there's some examples of some of the stuff here that we've done, like this. This is kind of, is this what I think, a prosthetic is what it is?
That is a prosthetic, yep.
So this is the kind of the curved nature it is.
Yeah, so that was printed on the same robot. And basically the idea behind this is that it's for a child who wants to use a running prosthetic, but these can be incredibly expensive when they're made by hand.
Yes.
And as you know, a child grows very quickly, which means you might have to get them every 6 months like you would new shoes, but that's generally far too expensive. So by printing it, you reduce the cost and you can customize it to every single person.
So there is an accessibility to things. I know even we're looking at stuff here that are like insoles for shoes and like surfboard fins and different things, but there is an accessibility things in terms of like a cheap, but also that if someone's even on the other side of the world or even in a a less developed nation, that if they have one of these, that you don't have to spend that extra money. You can just have one piece of kit that develops everything else.
Yeah, and it also means you can make it where you need it. Most of the time we make things in one part of the world and ship it across to another part of the world. That's a lot of CO2, and we all know that's bad for the environment. So by using additive machines, additive robots, we can bring the manufacturing to the person that needs it rather than shipping.
So apart from the shipping, you're shaping the manufacturing process, but you're also kind of shaping the future and making it in a sustainable way that means that there's actually a world left at the end of it.
Exactly. Yeah.
This is awesome. SFI Centres here at UCD doing something that's shaping the future. I have thoroughly enjoyed my time here at UCD today, where I got to visit centres Icrack, Insight and iForum and have a chat with some wonderful people, inspiring people. And that's the message that I want you to take from this little video, is that when you meet a scientist, technologist, engineer, mathematician, aspiring artist, anything like that, glean some of their enthusiasm and take their passion and maybe own a little bit of yourself and see how you can get involved or how you can be inspired or even benefit from the research that they do. That's what we're trying to do here at the UCD Festival, is kind of inspire and get people involved. And we're really happy to have showed off a little bit here of the research centred at UCD. Blah, 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 blah.